Next session is 2B, Grid Operator Use of AI and Advanced Methods Within Power System Applications. And sharing the session, we have Laura Walter, Senior Lead Data Scientist from PJM. Laura?
Good morning. It's my pleasure today to moderate today's discussion. As many of us know, AI is no longer just a research topic. It's becoming a practical tool shaping how we operate, plan, and secure the grid, although also still a research topic. From machine learning to large language models, AI is starting to influence nearly every corner of our industry. Today, we'll explore how leading organizations are putting AI to work across different aspects of grid management. We are joined by a stellar lineup of experts today. Michael Parran, Manager of Grid R&D at MISO, Tongxin Zheng, Technical Director at ISO New England, Shawn Monroe, Principal Strategist for AI at Hitachi, Vantara, and Aidan Tuohy, Director at EPRI. So we'll get started with you, Michael.
Good morning. As I was introduced, Michael Parran. I lead our grid R&D team at MISO. And I always jokingly tell folks that it is the mid-continent independent system operator, also known as MISO, not the soup company. Some people love to say MISO, and anyway. My point to that is we'll talk about context and why context matters as I get into the conversation here. But let's get started. And MISO, its footprint is in the middle of the country. It scales, covers 15 states and the Manitoba province of Canada. We monitor roughly 80,000 transmission lines. And last year, we had roughly 33 billion market transactions. Let's get to why we're here today. We were having this conversation earlier today, how if you listen to the news today, it will feel like artificial intelligence in our industry is this relatively new thing. And I beg to differ and say that machine learning depends on how you define artificial intelligence. Machine learning has been in our industry for quite some time. However, again, going with where the industry is and where the conversation is, I would argue that it's in several aspects of our business. So whether we're talking about actual use cases we are actually doing today, or things that we're exploring, where you're talking about markets, transmission. Today, we're going to be talking about specifically operations, in terms of a specific use case, but it has been with us for some time. Oops. So if you've been in this industry for at least a decade, if not longer, we've been talking about one problem specifically around how do we retain information as some of our veteran operators, folks in the control room, start to either retire or go to other parts of the business. And so as we started to think about this problem, we realized that for the new folks coming into the control room, it takes some time for them to become proficient with just understanding control room procedures and also just some of the nuances related with the bulk electric system. And so there's a lot of advances happening around large language models, and it's like, hey, this seems like an opportunity. Now, we realize that we could possibly use this to kind of bridge some of the knowledge gaps with some of our new employees, and also preserve some of that expertise. So, what we did was we actually started developing a digital assistant. Now, I want to be careful here. This is not something that you're going to see in the control room tomorrow. This is still very much R&D, and I say that to you, but I also say that to the folks back at MISO in the control room who get excited about some of the things we're doing. We had a very narrow scope to start with. There are several use cases we could have explored, but we started with very static documents. If anyone's been associated with the control room, you're very familiar with op guides and procedures. They look like text. They have graphs, charts, screenshots, logic flows. They'll also have formulas. And so what we were looking for from the large language models themselves is actually being able to take that content, figure out, asking it a question, figuring out which op guides and procedures to pull, and then synthesize that information down to answering the direct question that we needed. So we were successful, but I'm jumping ahead in the story. So let me walk you through the journey that we actually kind of went through. We did recognize that the technology in and of itself was not the main issue. There have been some major advances in these large language models. One of the challenges we realized very on was that we had to develop reliability and trust that people could, they were actually going to perform the way that we intended them to. If you've used any of these large language models, they provide really good answers, and I would say good enough, but we're talking about the control room, and we don't tend to take risks in our control room. Good enough is not the bar that we're searching for. So trust is not what you and I would develop as people, but what it looks like is accuracy. What it looks like is providing verifiable information and sources. And so, because if we don't have that, then people will lose confidence in the tools, or they'll be in a position where they're making some very risky decisions, and we couldn't afford that. So adding another layer of difficulty, what I will say is these models have been trained on normal human language. And so, but when we talk about the control room there, it's very nuanced. There's what we call operator lingo. There's just certain things and phrases that they use that aren't part of the normal vernacular. Also, again, going back to what I said before, making sure that the information that it's pulling from is grounded in actual op guides and procedures. We cannot afford for it to be hallucinating. I think you can imagine why that might be a problem. And then actually developing questions that real operators are going to be asking, making sure it has the right answers as well. Now, as we talk about any journey or as you're thinking about making a trip, we also wanted to be thoughtful about any other things we might perceive that we need to be aware of. So these were kind of the known knowns that we knew we were going to have to navigate. In our industry, security is very important, especially when we're talking about the control room and the bulk collector system. You have very sensitive information that's confidential. There are several compliance and legal concerns that need to be navigated and thought through. I've done innovation in several aspects of my career, and I would say when you're at the tip of the spear, there are some things that you just have to be aware of and thinking about. And this isn't because you're leading the industry. Even if you're doing innovation within your own company, there's things that you have to think about. Last but not least, also being very intentional about the specific stakeholders we wanted to bring along on this journey so they would support this effort and help us remove any other obstacles that we might encounter. So what that looked like for us in terms of our approach is actually working with folks who had either been in the control room, either support the control room or their leadership. As we were, so that for us looked like developing a suite of questions and answers, and also iterating with them. Now, these folks are very busy, so being very intentional about the time that we have with them, and finding different ways to interact with them besides just your normal meeting cadence, things of that nature, so that we can keep the momentum going. Again, we're also working with engineers, and so it was not going to be just a vibe. It felt good in terms of it was working. It had to be something that could be quantifiable. And so we spent some time thinking about metrics so that we could have something that we could show them in terms of the progress that we were making. If you've done any work in this space, I will tell you that retrieval augmented generation, it's a technique also known as RAG, is really getting at the heart of some of the security concerns. So how it operates is ensuring that the information, the model itself is not being trained on the bulk collector system, but and also meeting some of our security and NERC compliance things that we need to meet. It also helps with traceability and verifying that where we're pulling information from. So if we needed to audit anything, we could say, okay, this is where it was pulling it from. So this is really good. If you're not familiar with it, I'll tell you to take some time to kind of learn this because it's very helpful with several of those concerns. My friends in legal, risk, and compliance, we spend a lot of time with them. And what I will say to you is that those relationships already existed, just given some of the things we've done in the past, but bringing them along, answering their questions, and educating them when necessary, so they were along with us on this journey as well. And last but not least, and this took us a while to get to, but developing an environment where we could test and see our results, but doing it in a very consistent manner and being able to automate that process was very important for us so we could see how we were progressing along our metrics. So let's talk about the metrics. I would say the first two were probably our North Star in terms of where we're headed. So, and I'm jumping ahead a little bit, but what I will share with you is there's a lot of metrics out there. For us, we landed on these five. The first two, as I said, were kind of telling us where we headed in the right direction. The other three, I would say, so and to that point, accuracy, again, reducing the amount of hallucinations, were the kind of the two primary things that we focus on. The other three would provide how the other two were actually performing as well. So if it's pulling the right information, if it's pulling the right documents, it's actually pulling the right content. And then when a question is being asked, what type of context does it need to consider as it's digesting the question and coming up with its answer? Moving along, I will say this next slide is really breaking down what are the areas that we could focus on to actually make improvements in accuracy. So the first, when we talk about semantic context extraction, it's really about when we ingest information into the model, how do we make it machine readable? And what I mean by that is when you and I look at a document, we know what a title is, we know what a page number is, we know page numbers operate like this. They operate, if this is number 9, this is number 10, that's the order that it works in. And so there are things that there's techniques involved in actually helping large language models understand when it's extracting information, what it's supposed to do with that information. The next, going back to my analogy around context, the reason why you know that MISO in an eSig environment is around energy versus soup is because there are different things that you can just relate with. And so we're not talking about flavor, we're talking about actual energy or the electric grid. And so context is really important. And there's things that the models can pick up on either in the information it's pulling from and the question itself, to give it the context to help it make the right decision in terms of what information is needed. The third item around prompt optimization is really when a question is being asked, what can it do to make sure that it is actually honing in on the right answer that it needs to provide back to the user when they're asking it. The last is you may be familiar with it, but it's actually looking at the different large language models and seeing which ones, how they perform as we were looking at our metrics. And I want to be careful here because even as we're talking about, let's say you're focused on one model, even in that model, it has different versions, it has different instances of that model as well, whether you're talking about a mini or a nano or just the full model itself. And so just seeing how there's pros and cons to each of those. So looking at our metrics from that perspective as well. And what I will tell you, we're still on this journey. So we've only probably leveraged or got information on 2 of these. But so that we have a lot more way to go. But what we were able to observe is from an accurate perspective, we were able to see 20% improvement with some of the things that we've done. Also from a hallucination perspective, being able to get into the 90th percentile in terms of really reducing its ability to answer a question with something that it shouldn't, or being able to gracefully say, hey, I can't answer that question, or I need more information, because that's also an acceptable answer as well. So let's kind of wrap up here and talk through what did we learn. And so this first one, what I will tell you is for us personally, this took some time. Because of our posture around security, it took us in our normal R&D environment, what we're used to doing is it did not work. And there were a lot of constraints and things that we had to kind of work through as we pulled in different elements to get the large language models to work in our environment. And so we went through probably 2 or 3 different iterations. We got to a space of where we could actually, I would almost say, now I'm going to use a kitchen analogy of cooking, where we could actually cook. And so that it just took some time and progressions and different iterations to get to that point. So I would advise anyone who's going on this journey to actually take some time to think about what's the right environment and what are you trying to accomplish and or do. Second, this would not have been possible if we weren't actually working with the folks in operations, whether it was their leadership, whether it was the folks in the control room or the folks that support the control room. To that point, this last point is as we were making successes and as we were getting wins, we're looking for a slow burn. And I say that intentionally because if they got too excited, they would come back to us and say, hey, can I do this? Can I do that? And we'd have to remind them, hey guys, this is still R&D. It's going to take us some time before we have something that's production ready for you. However, listening to their different use cases, answering their questions, keeping them engaged was very much important to the success of this project. Again, thank you for this time. This is my first eSig conference. I'm glad to be here. I will also say, if you're very much interested in this topic, I'd love to talk with you afterwards. We're still a young team. We are building our team, and whether it's around AI, stability, large loads, and operations, these are things that we're very much excited about. So thank you.
Thank you so much, Michael. It's actually wonderful to hear that there's similar things happening at our sister ISOs to PJM. Next, we have Tongxin Zheng, the Chief Technologist at ISO New England.
Thank you, Laura, for the introduction, and good morning, everyone. And my name is Tongxin Zheng, I'm Chief Technologist from ISO New England. So I'm leading, just a little bit about myself. So I'm leading the R&D department at ISO. So our research areas include the electricity market design, power system operation, planning, and also emerging technologies such as cloud computing and AI. So I'm also responsible for the software development for market simulation and resource adequacy assessment. So as I mentioned that the R&D efforts. So we're turning our effort a little bit more on the AI because this is a hot topic, and we know that we want to understand a little bit more about what the potential AI and how it's going to be integrated in our system. And I know that you mentioned that the MISO had done a lot of work in this area, and you see there's a challenge. We're actually seeing the similar challenge you have. So today I'm very happy to be here and to share with you some of I'll call it the prototype use cases, and some of them actually is put into production. So, okay, so let me get started. This one, right? So, okay, down arrow. Okay, so high level. So why do we need AI in the system operation and planning? So I just want to highlight a couple bullet here. So one is that we're really seeing that evolving resource mix changes. This is really because of, I think everybody know that every ISO, every system is going to clean energy transition. And we see a lot of resources, for example, the renewables coming in, especially PV and wind resources. They are really affected. Their output are really affected by the weather conditions. So this is actually bring a lot of uncertainties into the control room, I would say. Actually, not only control room, but also planning perspective. So I see that at that particular point, we're saying that the forecasting is actually is essential. If we want you want your system operation to be more kind of efficient, more accurate, and I want the forecasting to be accurate. Hopefully, 100%. I'm sure that we're not going to be able to achieve that. So the other thing I want to see, I think this morning also our manager and control room also mentioned that the complexity. And you also know that there's a lot of resources are being integrated into the system. Small solar behind meter, and we have the batteries. So the question is, if we want to manage all those resources, obviously is not doable. You know, like I think this morning the gentleman asked about the DERs, how we're going to integrate the DERs. Well, high level question, yes. We're going to use DER aggregation rather than controlling individual DERs, right? That's how we manage complexity. But you also, you know, John in the morning also talked about there's a bunch of complexities related to the integration of those resources, you know. So also you look at the for quarter 2023, we're talking about the cluster studies and we want a faster resource interconnections. I believe we have a session, you know, tomorrow, I believe, or maybe the end of this, I mean, the afternoon, talking about, you know, how do you speed up the interconnection process? And I heard a lot of people saying, okay, let's do AI. So now my next point is that, you know, we need the business process automation, and we believe that AI can play a key role there. The third point I want to bring up here is that, you know, we have a decades of great operation, you know, system operation, and we have also market operations. And recently, maybe decades ago, we're talking about, we have the PMU data. We have a massive amount of data. So how do I learn from those data? Okay. So how do I utilize those data and such that, you know, we are moving towards what we call the data-driven approach, right? To operate the system. And so I believe that the machine learning and the big data analytics are going to play a big role there. So with that, I want to, you know, share a couple of applications, you know, I call application use cases here. And I classified into kind of three kind of bucket there. So one is talking about the forecasting. So I think everybody know about that, I think up to date, what is the most successful application of machine learning or AI is load forecasting. That date back to 1990s. Right, so now we're still using AI-based method for the load forecast. So I want to very quickly run through this because I know that everybody know about this. So our, you know, we have been using that, you know, AI and machine learning for the you know, for load forecast for a long time. So we have been, you know, setting a target. For example, you can see it here. We want to be control our you know, MAPE to be 1.8%, you know, in the October timeframe, October to May timeframe, and you know, summertime I want to be 1.6, right? That's our goal. So if you look at the next slide, we'll see that you know, there's a big increase in the renewables, and we're seeing that there's a lot of uncertainty coming into play. So I think John in the morning also mentioned that, oh, okay, we can get 100%. So how do we do about it? What do we do about this? We would like to operate our system to be on a range of conditions. We're not going to be operating on a fixed point. So what we had before is point forecast. So now it's time to move to probabilistic forecasting. And so we are working on in this area. And so next slide shows really just a, you know, a framework we're thinking about. Currently, we're talking about using establishing a uncertainty quantification framework. Basically, this facilitates us to shift from the current operating process, okay, reliability-based operations to a risk-based planning operations. So this figure, I mean, this figure shows our framework. We're saying, hey, can we use generative AI capability to generate, for example, probabilistic weather forecast, right? And then we're gonna say, hey, with those information, we'll feed into our existing load forecast and wind forecast and PV forecast. Also, we will generate probability distribution of our load forecast, right? And then we use a coupled-based scenario generation engine, which take into consideration of the correlations among those, you know, wind, PVs, load, temperatures. All this is correlation will be captured in the corporal-based method, and then we'll be performing, like, for example, scenario reductions and generating the scenarios to be studied, and importantly, the probability associated with that. So with those information, now this opened us the door of risk assessment. So that will be the last the last column on this slide, which is talking about, like, we can do capacity analysis, because that capacity analysis shows that what's the probable distribution, right, of your capacity available, or your capability to meet load. We can do network and security analysis, outage coordinations, and look at risk assessment, and even drive to market operation, because we could use this information to construct maybe opening reserve demand curve. So those information can be used. So there are a bunch of things that more and more can become based on this uncertainty quantification framework. Moving on to the next one, we're talking about the process automation. So I think we all know that every organization had their own private information, and they have a vast amount of knowledge that developed over the years of operation. Okay, so there's really a need for for a what we call the chatbot. Okay, so those information, for example, the operating procedures, the market rules, they are project information, they are exist in the organization in different formats. For example, document, like a Word document, PDF files, web pages, videos, audios, images, all the stuff is scattered around the organization. So how do we use this vast amount of knowledge and translate it to the new employees, or maybe not even new them, or the designer, because you can see that because such complex system, there is when I design a new market, we want to understand what portion or what business has been touched, what market rule had been changed, what are the connection there. So this is gonna, this a chatbot, for people to quickly realize the connections, evaluate the impact of their design, or maybe training. So this is very useful too. So we feel like this is going to be very useful. So we did a pilot. I still call it pilot. I think there's a lot of concerns about, the information policies. And so we did develop the, chatbot pilot, and we use Amazon Q Business. And connecting many internal resources, data sources, and the technology used is our retrieval augmented, generation technology. So this is we're saying that initial testing shows that works pretty well. So to give you a little bit details about what is rack architecture here. So you heard about this rack. So I think the very important thing is rack is really combination of your private data, you only private to the organization, and also pre-trained large language model. This is a combination of the two. So we did a small pilot there. So for example, we want to generate a report. So how this works? So we got our data, information. I say, like PowerPoint, PDF files, and the procedures, and we loaded them up into vector database. So that's through this, Amazon services. We put them into the vector database. So, that means that is you can consider a vector database is your knowledge base, basically your private knowledge base there. And then, then when the writer come in saying, I want to write a report, and that report saying you can give for example, the outline of the report, and we put them into a Word document that shows the prompt. And that prompt goes into the system, basically goes through the large language model, then they go to the retrieval retrieval the information from the vector database and get the relevant information because that's a specific report. Is normally most of the report are using information of your system, of your organization. So information retrieved, and we send this information back into the large language model, which is pre-trained, and which may not know much about the power system, or they know about it, but not much about the private information of your organization. So then they will generate a report based on the prompt and private information. And then you have to have a human in the loop, which is going to verify that, the report. So this has been successful, meaning that we are able to generate those. But whether the quality is big or not, I think that still need a lot of verification process there. So next we're talking about, say, hey, the large language model there, and this is RAG process is pretty good, what's next? And I think we're talking about the process automation. So recently we can see that agentic AI has been on the rise, and everybody talking about it. And agentic AI is an autonomous system that can, it can reason, for example, it can take actions. I think the key point is take actions and achieve a predefined goals that with limited human interventions there. So there are the key benefits I will show here. So you can improve, for example, efficiency of business operations. That means that they have a better workflow management. They also have, integration. They can integrate existing software systems. I think this is really the key. The integration of large language model and the existing software system. It's like a building agent that it will do the things for you automatically. So we're exploring a couple of potential AI, agentic AI, applications. So one thing I want to show here is that we're working with in Harvard University. So we're trying to build you can call it, dynamic security assessment agent. Okay, so this is the figure shows here is basically, a basic function we're talking about. So when we're talking about is that, hey, we need to have a generative capability so we can do time series forecasting, and it will generate all different type of scenarios, for example, renewable scenarios, load scenarios. Then we're going to say, hey, with this information, how would I want to perform dynamic security analysis? So now we're going to build a DSA agent. So the DSA agent going to interact. We say, get the information. We're going to run, let's say they're going to prepare all the data input, for example, for, let's say maybe a, forward, or maybe PSSE, data format. So we plug in and we run through this. So run through this, and then the agent will be able to, modify the data input and run the security analysis. And then the important thing that we'll say, if the, for example, if there are something wrong with the, results, first of all, it's a software issue. If the software issue, then you go back and change it, right? So the normally process will be an engineer going to do this. We want the agent to do that. And then the important thing is that the results, right? There are a bunch of results coming out of these different scenarios. We want to summarize the result and present to the engineers, right? So this is a very high level goal, and we're thinking that this, if we can be successful, going to relieve, you give the engineer a big relief. So I saw that I have 0 minutes left, but I still want to very quickly go through this. And I think everybody already know about machine learning and big data analytics. And I think in the previous session, we talked about situation awareness. So this one, I want to really, really very quickly to showcase one of the application we did using through machine learning. So as you can see that, New England is actually exposed to extreme weathers. So it's definitely, it could be tropical storms like hurricanes. We can, and winter storm, cold snaps. So predicting the impact of extreme weather on your systems is extremely important. So that's why we actually, a couple of years ago, we developed a online weather look ahead study tool that's called OWS, and to enhance control room situation awareness. So what this tool is doing is that actually given the weather forecast, we'll be able to perform, analysis and prediction of outage of transmission element in the system. And so then we will alert system operators of the potential transmission outage and with elevated outage probability. Everybody know that transmission outage probability is small. So you have to be saying that, oh, with a given, like a storm coming in, so how you gonna see the immediate increase of probability of certain outages? So we're gonna alert the system operator. So another thing is that we actually did is that we integrated this online look ahead study tools with our online cascading analysis. So with the increased probability of outages, and we'll be able to perform cascading analysis to alert the system, what's the impact basically. That's what this tool is doing. So I'm gonna skip this, but I want to highlight, I want to mention that this is a collaboration with University of Connecticut. So we're using the machine learning techniques in this process to estimate the transmission outage probability. So there's a bunch of methods there. So I want to just skip it. So this page really shows that it's a demonstration about what this tool is doing. So you can see that this is a retrieval of historical weather forecast, because we want to show how things work. So we are able to, in this slide, you see that we have shows 9 hours of prediction how the storm evolved. And then on top of that, we have the geographic information of the New England system. We have the transmission overlay on top of that. And then we show that, where you see the transmission outage probability increase. So you can see on the, I think it's on the right side panel, you can see the red color here shows which transmission element is need to make attention. So if I were to look at this and okay, let's do a study, maybe do another study to see, whether I need to protect that, that thing from happening, meaning that if that transmission got lost, what will be the system do? You can trigger the event analysis preventively, basically. So here's the key, takeaways. So we can see that the system has become more uncertain and complex, and hopefully we believe AI can help. That's not necessarily the generative AI, machine learning. Even the basic machine learning can help you. But I want to echo what MISO experience there is that we see the greater potential, but it remains challenging. If you want to put that into a control room and trying to help with mission critical process, I think it will take time to get there. And we have to address questions related to the data governance and cybersecurity and the regulatory framework. So one thing I want to share with you is that AI is very disruptive, and there's a lot of unknowns to our industry, especially we're heavily regulated. We're so focused on reliability. So for example, in our process, if we want to do any R&D or innovation in this area, we actually form a committee to review all these projects. So we have a data governance, we need review, we need cybersecurity reviews, and we have legal reviews. So all together, and also technology, right? All together, we had to make to go through all the reviews, and then we can make the initiative be successful. So that's the thing I want to share with you. Thank you for listening.
Thank you so much. It's always really good to hear about people taking uncertainty and risk into consideration. I'd had a really bad day at work and I predicted that X would happen and it didn't. And I was like, no, no, no. Well, I predicted there was an 80% chance based on history that X would happen. And then the next day my kid calls me and says, I missed the bus. And I said, well, you're not supposed to take the bus. Well, based on history, I think it was an 80% chance I was going to take the bus. And so kids are listening. Wrong way. Let's see.
I think it's here.
Oh, thank you. And so I'd like to invite Shawn Monroe from Hitachi Vantara to speak next.
Thank you. So good morning, everyone. I'm Shawn Monroe with Hitachi Vantara. I am the principal strategist for AI for Hitachi. So right now, I know there's questions like, why is he here? And I'm on panel with RTOs, so I'm going to be talking a little bit about what we're doing with Southwest Power Pool, but why Hitachi Vantara? You're probably sitting here thinking, I may never have heard of them. Hitachi has 578 companies, Hitachi Energy being one of our largest, and Hitachi Energy has been around for 115 years now. So my group, we're focused on AI, we're focused on data center, we're focused on architecture. We have a really great relationship with NVIDIA. We are coming in year 6, I believe it is, on co-developing with them. Now, what sets us apart from a lot of the other people, we didn't go to NVIDIA and say, hey, can we resell your stuff? We went in and said, hey, we've been working with data forever. We have AI that's been around for decades, and being able to do some analysis on it, we feel that we've got solutions we can bring. And NVIDIA started a new section called Solution Providers, which we're leading. And we co-develop with NVIDIA. And NVIDIA has been a key part of what we're doing with Southwest Power Pool. But it's not just my part of Hitachi. I'm running a one Hitachi group. I've got Hitachi Energy. I've got Global Logic, which is our consulting arm. I have our R&D group, Hitachi America's R&D, which we put about $6 billion a year into R&D. So Hitachi's addressing how can we bring new technology to the energy sector holistically, and we're doing it under our social innovations. So it's really exciting for me to be part of it. And I know a lot of people have heard about what's going on with Southwest Power Pool. So I'm going to start with what we're doing there. In conversations we were having, and I was learning more and more about your industry over the last couple of years, we were able to identify an opportunity that we thought we could help address with new technology. And this is the power generation interconnect requests. So with RTOs, as everyone here I'm sure is familiar, they get the requests in. It's got to go through certain processes, and it's got to go through a lot of analysis, and eventually it comes back with, yes, you can do this, and here's what the impact is. And then you have to make decisions. Is this of value for your company? So we looked at that process. We looked at the software and everything that's involved in that process. And we felt there was a better way to address it. And a lot of this is using new technology. A lot of this is using AI. So I'm going to jump around a little bit. As we're going to talk about the new compute processes that we bring and the current technology that's being used, AI is not a one-hit wonder. It is not, I have this new shiny gadget and it's going to fix it. If you look at it and say, I want to implement an AI and I need to clean my data so it'll process through the AI, and you're handling the whole process side of it and cleaning everything up, you will run into roadblocks on the compute side, on the capacity side, or as we're finding, a lot of the traditional software that is being used in the industry has been around for a while. It is CPU constrained. It is single threaded constrained, or if it's doing parallel, it's still CPU and CPU clock cycle constrained. So we had to come in and look and say, is there a better way? How can we use GPUs and be able to do real accelerated on compute? And like I just said, I can't fix one part without fixing both. So with us looking at it, we were able to step back and say, okay, if we bring this in, our initial target was, could I process that request to get to a 75% accuracy in less than a day? And with our surrogate models, with our processes, the answer is yes, we can. Now, to get to the accuracy we need to handle the whole process, oops, wrong way, to handle the whole process, to handle the software, there's a lot more that goes in than just the calculation. So we're coming in, we're saying from the beginning, how is the data coming in? How can we use technology to validate the data is correct and it's in its format and it's not running into certain challenges? And we're addressing it at that level. Then we're taking some steps to automate that if it meets these checks, if it fits where it's supposed to, it's going to go to the next step. And the next step's going to be prepping the data, validating the data, starting the processes. We're building surrogate models that are taking benefit of new technology, of GPUs that are drastically faster than CPUs. We're able to attack these problems with more data too, because it's not just the request that's coming in. You've got to look at all the data and do your studies to say, here's what the impact is, and here's what needs to be addressed as we're going through this. So we're looking at how can we do that better also, and how can we marry what you already have in place and adopt new technologies. So a lot of what we're doing is using, new surrogate models, new AIs that are out there, and introducing the hardware to do it. So modernizing the hardware, setting up simulations, setting up the software and the process, and really looking at it from a full holistic view. So our goal right now is being able to speed up the overall process of power generation interconnect requests by greater than 80%. Now, we've talked a little bit today, the other panelists have brought up LLMs, SLMs, different things like that. In a lot of what we're doing here, we're at the descriptive AI, using data you already have. We're at the prescriptive AI, which is algorithms, which is how you're doing these processes today. We're just drastically speeding it up. In doing that, everyone's made business decisions over the years, over the decades, that for me to come up with this answer, for me to come up with this solution, we're going to use this set of data. And because of time, because of other restrictions, you may have looked at the data and said, okay, I'm going to use 4 data sets, or I'm going to use 8 data sets, when you probably have 30, 40 years of data sets. If you used more in a shorter period of time, would your answers be more accurate? And that's where the joy of AI is. That's where the GPUs are. We can use the machine learning. We can use more data to get you into more value. But this is really the beginning. Now you get into what does my data look like at the end? And that's where potentially you're looking at SLMs. We're starting with an LLM like everyone else, but because your industry uses different definitions, you know, a region per Webster's is one thing and a region in your world is different. We're starting with an LLM. We're then reducing what we don't need out of it and training it specifically for the energy industry. And then we're doing the whole prompt magic in it and working at getting correct reports. So again, based on the data that's coming in, based on the data that we already have, we're able to give SPP and they're able to give their members better access to more reports. So this is really step one in how we can help address this. Getting into what's next is where it gets really interesting, because now that we're cleaning up the data, now that we're implementing GPUs and, you know, modernized technology on site, we're able to go into the next steps. If I've got the data and I'm processing at this speed and I'm getting these reports out, what else do I need to do? You know, we've got operations side. We're looking at forecasting. Forecasting is very important. Everyone has brought it up so far. But if you look at forecasting and how you're doing it, again, you are probably already making the decision that for my energy forecast based on the weather, I'm going to use X number of data points. And my guess is the data points you're using today are single digit data points to decide your weather forecasting for an hour from now or 2 days from now or 10 days from now. But everyone here probably has the full weather forecast for the last many decades. So being able to see trends, which is where AI is going to really be able to do it. If I can provide it more data to get more value much faster, that's a good thing. In several of the other customers I've gone to in the energy world, they are bringing up, hey, we're using this tool to do energy forecasting. And sometimes we have to readjust our forecasts every 15 minutes, but the report takes 30 hours to run. So why not modernize this, which is one of the things we're doing as one of our tools is one that a lot of y'all use, to use the GPUs, to use a better model. And let's bring the ability to do energy forecasting to almost real time. So the way I opened, wrong way again, really was this slide here. And it's more than just the title slide. It's really the art of the possible. It's where we're going. We talked about energy forecasting. I don't know if anyone here has heard of Earth 2 or Omniverse. Any show of hands, anyone? Nope. Okay. So there was a couple. It's a digital twin capability. It's a visualization. And it is one of USD's the standard that everyone uses. NVIDIA has modernized it because it runs so much faster on GPUs. But in weather forecasting, Earth 2 is specifically around weather forecasting. The general models that are out there are able to get you much more accurate forecasts at a 5-kilometer setting in, I think it was last year, going through a lot of the weather forecasting, it was able to more accurately predict the path of a particular typhoon 3 weeks prior to impact. So we're working very close with NVIDIA. We're working close with SPP on bringing weather forecasting into that section of the grid. And this is not just, hey, I need a better weather forecast. This is bringing the whole grid into a digital twin. This is not doing a 5-kilometer weather forecasting. This is sub 1 kilometer. This is much more accurate than anything that's been out before. But just because I can get you to that level, and that's going to be valuable for everyone on what do I do, where do I send the energy, how do I respond? We're thinking past that. We've already designed ways to give you solar production forecasting for your solar panels based on cloud coverage and everything else in this model. We've already done the same thing for wind and being able to see how well our wind turbines or other people's wind turbines are going to do, what they're going to produce based on accurate weather forecasting. We're taking it to the next level. We're able to now let you simulate weather impacts. What if scenarios? Hey, there's a storm out there, and what if it comes on shore here? Sorry, I'm from Florida. I'm used to hurricanes, and that's just standard for us. What if it hits here? What's my impact going to be? So you're able to use this tool, and whether it's hurricane, whether it's snowstorms, ice storms, tornadoes, you're able to start running simulations on the grid in your environment to give you, if this goes here, here's what your impact's going to be. But we're taking it to another level also. What if you know the storm is going to come there and you now need to produce less power there, more power over here? That goes back into the energy forecasting we're tying into this. But what if you're going to pre-deploy service trucks or utility trucks to go into an area that potentially is going to be impacted? What if you can take that to the next level and say, here are all the pieces and parts that potentially or most likely will be impacted by this weather event at that location, and you can make sure those parts are on the trucks that are being pre-deployed out. We're trying to tie it all the way down to supply chain to make sure that it's being delivered out the correct way. And at the same time, this will be able to give you much more accurate energy forecasting from 1 hour all the way out. Current goal that I'm being told is 10 days. So that's where we're starting to make sure that we can give you accurate forecasting there. And since we have the compute and the capabilities on doing it, not having to choose 4, 5, 8 pieces of information, we can run it with hundreds in a fraction of the time. So, I do appreciate everyone's time. It is my first time here at ESIG also. I do enjoy talking about this and AI and how it can help impact the industry. So happy to talk to anyone outside of this. Thank you.
Down there.
I'm clicking the same thing and it's just. Wow, that was the definition of insanity right there, is doing the same thing and expecting different results. Thank you, Shawn. It's fascinating to me that during my own career, I've gone from running a regression on the mainframe and it taking a half an hour to not even having enough time to go get coffee before results are in. So fascinating. Last but not least, Aidan Tuohy from EPRI.
Thanks, Laura. Appreciate the opportunity. Good morning, everyone. This is not my first time at ESIG. It's probably 25th or 30th time. But it is the first time talking about this topic of AI. You know, in the past, we've talked about resource adequacy or stability and other things, so our reserves, those types of issues. But and some of those have used AI underneath them, and we've been able to use some of these AI methods to support the operators and planners and the tools we're developing. But now we're starting to see this more narrow, more focused look at AI as we think about generative AI in particular, and the advances that have been made there by the AI industry in the last few years. So we've been looking at this at EPRI. EPRI, for those who don't know, is a non-for-profit R&D organization. We work across the world with utilities, transmission system operators, and increasingly now technology companies and others that are getting into this space. So I lead our transmission operations and planning research area, so everything from long-term planning down to control room operations and the work Vikas was describing earlier, as well as market design, system protection, other topics. So we've been looking at this across those areas. I'll talk more around the transmission operations and planning topic, but I'll end with some broader EPRI work as well that we're doing to support the industry as we adopt some of these methods. So when we think about the energy industry and the state of AI, there's a few different things that I think are big issues that are under development right now. So automation, we heard this already from everyone, both to this panel, but also even in the earlier panel as well. We are seeing more decisions having to be made. They're having to be made closer to real time. There's a real need for automation, and being able to do that often is a good use case for AI. I'll talk a while about both the process and the decision making. So there's different ways to use AI in terms of actually automating some of the processes that are done, the things like the interconnection processes that were just talked about. But also AI for kind of decision making as well. So you're actually doing optimization or simulations and using those to inform decisions. So I'll show some examples of some agentic AI use cases we're looking at in a while as well. One of the things we're really looking at as well is just thinking about the use cases. There is a lot of cool new technology coming out. It's not always clear how mature it is to be able to apply in specific areas. It's good to understand what others are doing. So we're trying to develop a use case repository. I'll mention that in a while as well. But what we're seeing is a lot of these, there's some really nice new ideas. There's a lot of good pilot projects, but they're still at that kind of pilot stage. There's relatively low levels of maturity. It's good to see things actually starting to get adopted. But I think even today we've talked a lot about things that will happen as opposed to things that have already happened in this space. And so a lot of good ideas, but really trying to understand which are the use cases that are kind of the lowest hanging that also give us the best value from actually investing in them. So we're trying to look at that idea of which are the right use cases. And then obviously there's a lot of different solutions coming out as well, whether that's the actual platforms, the various companies that are out there providing these solutions, HPC, GPUs, other types of technology that are out there. And then we see a huge amount of kind of startups coming into this space and providing solutions. So a lot of what we're looking to do is trying to understand how do we embed that into the various pieces of research that we do as a applied R&D organization. So kind of breaking it into these three big buckets really here in terms of how we think about our AI in the research area. One of these is kind of that use of LLMs to complement expertise. You know, you can do things quicker with LLMs. They're not always accurate. You have to be careful on how you use them. But being able to actually complement expertise with a lot of the insights you can get from these tools. So you're not, it's not as manual anymore. There's things you can do a lot quicker. I'm sure all of you have done, as you've even heard about topics here today, you can look up at your favorite ChatGPT or Gemini or Claude or whatever it is and look up a particular topic a lot quicker than you used to be able to. Hopefully you have the ability then to check the references and citations and all that. But it's very useful for that type of bringing additional expertise. Another thing is we have worked over the years with developing software tools to support planners, operators, others in the industry, whether it's integrating new technologies, modeling, simulation, being able to integrate AI into that. And I'll touch on some of the examples we have there. Vikas showed some examples earlier on for those who were in this room in the morning session. But bringing AI, whether it's generative AI or machine learning or GNNs, other types of AI into the EPRI software tools, another big focus. And then the last thing is adoption by members. So we're helping folks with things like roadmaps and sharing use cases, being able to understand where there's potential use for AI, as well as things like developing a grid-focused large language model, for example. That's one of the efforts we have right now underway at EPRI. So I mentioned use cases. We'll have a repository coming out later this year. We're actually putting a survey out for both the utilities and system operators, as well as technology providers. I maybe provide the link in the slides later when we send them out, but I don't want to get through the specific use cases here, but we've gathered over 260 different use cases for AI in the power sector that we're kind of parsing through right now to see which are the maturity levels, which companies are addressing different parts of those challenges. And so the survey will allow utilities to help prioritize which are the ones that are more valuable, which are the ones that actually have the data available, that they'll be able to trust the results, all the examples from earlier, as well as then survey the technology providers in terms of what tools they're developing that can help meet some of these use cases. So this is something we've been developing over the past year, we've done workshops here in the US and Europe and the Gulf, other places to be able to gather some of those use cases and start developing out this repository that we'll be hopefully putting out sometime in December or so that folks can interact with that. When we think about how theirs are actually used, then so operations and planning, we're solving problems, right? That's the main focus on what an operator is doing or what a planner is doing. And to do that, you're doing a few different things. You're making sense of the data, the models. You're making sense of what the problem is first. You're gathering the data, ingesting the things, and trying to understand where you are. You're then actually making decisions and then planning that simulations and in operations, maybe that's taking a forecast and understanding what that action you're going to have to take is going to be. And then you're actually taking that action, whether it's writing a report and a planning case, switching lines, dispatching, whatever it is in the operation side of things. But all of those things are things we're constantly doing. That's how we think about kind of control rooms, how we think about planning studies. But we've already heard a lot about the complexity and additional data and scenarios that need to be managed. Less experience, we're getting these kind of unstudied conditions or newer conditions that are coming up, and as well as some of the retirement that we're seeing in the industry and just that higher pace of change in general, whether it's large loads coming on, inverter-based resources, 765 kV build-outs, whatever the case may be, there's that greater challenge. So where we think AI can help is two big ways, really, in terms of the actual process and bringing the data in, automating reports, being able to make sense of the data, so that kind of sense making and action making can be automated in a way that AI can really help beyond the typical automation we've done in the past, but actually kind of agentic AI to automate some of that would be a good place to use AI. And then the actual decision making, the simulations that are needed. So there you're talking about things like using GNNs to be able to better understand, are you getting stability constraints on the system, or are you being able to better run production cost models a lot quicker, so you can run a lot more of them and do broader types of analysis. So these are the types of ways we've been seeing solutions. And just to give a few of them, Vikas mentioned this one already, the alarm data one. That's one we see a lot of promise in. It's the idea behind it is really, as Vikas talked about well earlier on, keeping the data and the LLM somewhat separated, so you have that safety level. You can query it with a set of predefined queries. You're not just handing all this data over to an LLM and saying, make sense of it for me. You're giving it a structure to be able to think within, but then you are actually able to use it. And so we've been testing in different ways. You can go in and say, what are all the high voltage alarms that I've seen in the last 24 hours, or show me all the alarms at this particular substation in the past week, and be able to query that. So right now we'll be able to use it in a way that you can really understand what's happening in alarms, which has always been a big issue for operators, is just the amount of alarms coming into the control room and being able to make sense of them. The next step on that then is to actually use machine learning or other methods to be able to start making predictions, or being able to help identify the mitigations that are going to be needed to manage some of those alarms. So that's one of the key use cases we see, and it's a one that helps because it's not actually right in the loop. It's still the humans very important to this, but it's helping them and giving them more information and insight that they can then use to make decisions. Another one in a similar way is as a planning assistant we're looking to develop. We've been working with a few utilities and system operators to test this out here, and hoping to have some useful results. We've already done something here in the protection space for protection modeling, and we're starting to expand that into other types of planning studies. So the idea here again is to have this kind of assistant sitting in the middle that works with an LLM, but also works with your own documentation, your own scripts, your own guidelines, and local data, as well as things like software manuals and the understanding of what the actual software is doing, and then be able to kind of orchestrate studies. So the examples from the protection side, we've been able to do kind of relay setting, where traditionally there's a lot of manual interaction and back and forth and checking. You can go out and say, I want to do these studies. Tell me what assumptions you're going to make. Ask me questions to help you get a study set up, and then it goes and does the study and it puts it out in a report in the format you need from your perspective, the way your company puts these reports together. So we've seen it speed up a lot, the kind of studies that get done in this area. This is intended as well to be kind of technology neutral. It doesn't have a whole lot of dependencies or anything like that. It's fairly plain vanilla Python code that can then run with a whole bunch of other software, so that you're able to leverage the existing software you have or additional new software. And then the last one's kind of more in that simulation space or the decision-making space, where we're looking at synchrophasor measurements, so leveraging PMU data. Two different things there we're doing, one on the state estimation side of things, where again, a lot of these, but both of these are model independent. You don't actually need the network model, but using a deep neural network to be able to train based on previous state estimation snapshots, so that if you do have missing data or you wanted to understand what the state of the system is, you can leverage some of this to be able to provide this to operators. It's something we've seen a fair bit of promise in. We've been trying it with a few different places. And then the same thing on the security assessment, where you're looking at using historic or past dynamic simulations and taking a large amount of those with a graph neural network model to be able to assess, are you getting close to stability indicators? So we've identified a set of frequency, voltage, transient indicators, and you're able to then use the PMU data together with this model to assess whether you're getting closer to having instability. So these are a couple of the kind of things we're looking at from an EPRI perspective in terms of being able to use AI with some of these software tools. And if anyone's interested, happy to kind of talk about more offline. Last two things I wanted to chat about before time runs out here. One is this LLM topic, so I'm sure everyone here has gone to their favorite LLM and said, what is whatever the case may be, what's the current state of grid farming, looking at Julia, grid farming inverters in the world, and it'll give you back some answers. You don't know whether it's right or wrong. There's no understanding of how good these are. So one of the things we looked at doing, we're doing this across the power industry, but I'm just showing the operations and planning topics here, is we worked with our SMEs within EPRI to develop a set of multiple choice questions, so anywhere up to about 50 questions. Justin down there, for example, on the meteorology side of things, and a few others on various topics, and then had these multiple choice questions that we gave to the different models that are out there. We categorized them into easy, medium, hard. And similar to what you see in, for example, you'll see these tests being done for physics or for law or for medicine or other things. We want to try and have a similar benchmark for the power industry. So across each of these, you can kind of see that the average performance, 75% to 90%. Now, some of that obviously is just the questions we pick, and we'll continue to improve this, and would love to work with folks as you all are doing similar things to kind of have that set of questions that can be most useful. But trying to look at how good these are at the different issues. You can obviously see some of the hard questions, they're not quite able to get maybe half of them in some of these topics. Some of these questions are numeric questions, some are more general questions, but each of them had a multiple choice option. Sorry, wrong way. And we also looked down at a lot of the different ones. So this was earlier this year. I think there might be some new models out since then, but we'll continue to kind of push updates for this every 6 months or so. We'll have a first report out. So these are the different large language models that are out there. You can see obviously the more recent ones, Grok 4, Gemini 2.5 are able to perform better. This is across the full set of questions. And then as you go back to some of the either the quicker ones, Gemini Flash or whatever, some of these they don't perform quite as well. So we're going to continue tracking this as part of some of the work we're doing in the AI space to be able to understand how well you can trust these on the different topics. And so the next step here as well is to move beyond these multiple choice questions, but also have short form answers and kind of more context that you have to give, so you can kind of see, can it actually work through a problem and give some solutions then on that as well. And this is all part of a lot of the work we're doing here is part of our Open Power AI consortium. This is an effort we started earlier this year at EPRI. It's across the full power sector, so not just the ops and planning, but also our asset side and our generation and nuclear side of the house. There's a wide variety of different things we're doing there, though. The AI models there, we have a few different things going on. We're looking at a large language or potentially an SLM for the power grid, where you'd have all of the EPRI documentation as well as expertise and potentially even member information as well to have that kind of chat GPT for the power grid. Also looking at helping folks develop roadmaps for how they're actually adopting AI and developing the data sets and information that curating that so that technology companies can come in and use that to actually test and build their tools on top of confidential but real industry data, so that we're able to do that in a kind of a secure way. Another thing is that AI sandbox. We're looking at working with the various technology companies, the startups and others that are doing work in the AI space, and then connecting them with the various utilities that have interest in different types of AI use cases, to be able to kind of do that sandbox where you can actually test and get some results fairly quickly to get a sense of whether there's value or whether there's promise in a particular method that you can then kind of further pursue. And then the implementation piece, just working with the members of this to be able to kind of partner up with both the technology providers and the member to be able to test this and actually implement this in whether it's in planning studies or eventually in control rooms, so they may be some of the last places to adopt some of these tools, but being able to bring those into the power industry. So there's a few different things there. One thing I should mention here that we'll be launching soon in that kind of I guess in the middle one is a competition. So those of you in the room that are familiar with the unit commitment problem, you know it's a mixed integer problem. There's a lot of challenges around getting that to be fast enough to be able to run the amount of cases you might run for, say, a resource adequacy study. We're looking to do a competition. We're launching it here in early November for folks using a real world data set to be able to assess speed up that you can do. So you develop a kind of a digital assistant or AI powered assistant that can sit on top of a unit commitment model and then be able to run that quicker. So keep an eye out on that should be coming out. It'll be an open competition for the folks who are doing research or developing tools. They might be interested in actually applying those to those tools. And for those of you who are using unit commitment models, there might be some interesting insights around how we can speed those types of models up and what type of value AI can bring to that area. So I think that's it. Thank you.